Okay, so for this video, we will be discussing the derivative of trigonometric functions. So the derivative of trigonometric functions are given by some formulas for which you have to familiarize and memorize. Okay, so here in our formula, so we have an arbitrary function u, okay, which is any function that can be differentiated in terms of x, okay, so with respect to x. So the derivative of sine of u with respect to x, so that is equal to cosine of u multiplied by the derivative of u with respect to x. Okay, so whatever function is inside the trigonometric function sine, so we will multiply its derivative outside. So it's an extension of the chain rule, okay, that we have discussed earlier, okay, in our earlier lessons. Okay, so all you need to do is memorize those, okay, basic formulas. So the derivative of cosine of u is negative sine of u du over dx. For tangent of u, its derivative with respect to x is secant squared of u, so multiplied by du over dx. For cosecant of u, its derivative with respect to x is negative cosecant of u, cotangent of u, times du over dx. For secant of u, its derivative with respect to x is secant of u, tangent of u, then multiplied by du over dx. And then cotangent of u, its derivative with respect to x is negative cosecant squared of u times du over dx. So you have to memorize these differentiation formulas. Okay, so you should also review all of your identities. Okay, so from the Pythagorean identity, sum and difference, double angle, half angle. So all of those identities and so on, I think there are more. So, but at least those four. Okay, so review all of your trigonometric identities involving those. Okay, so because it will be very useful in simplifying, okay, derivatives as well as simplifying the final answer. Okay, and along the way, so we might also apply trigonometric identities while differentiating. Okay, so that's up to you on how would you memorize those identities. Okay, so let's have some examples on the applications of those formulas. So find the first derivative of the following. We have a, so y is equal to 6 secant of 3x. Okay, so for letter A, we have y is equal to 6 secant of 3x. Okay, so in finding dy over dx, so we must differentiate with respect to x 6 secant 3x. Okay, so from our product rule, so recall our product rule, if we have a numerical coefficient, then we can take that out of the differentiation. So this will become 6 multiplied by the derivative with respect to x of secant 3x. Okay, so this is a direct use of the formula. So here we have the derivative of secant of u with respect to x is secant of u, tangent of u, times du over dx. So in this problem, okay, so our u obviously from here is, our u is 3x, right? So our u is 3x. So therefore, applying the formula, so we will have 6 multiplied by the derivative of secant 3x is, again, that was secant, it will become, so if u is equal to 3x, then its derivative will become secant 3x tangent of 3x multiplied by the derivative of 3x. So this will now become secant of 3x tangent of 3x multiplied by the derivative of 3x with respect to x. So that is multiplied by 3. So therefore, our derivative with respect to x is, just simplifying this, so 16 times 3, that would be 18. Secant of 3x tangent of 3x. Okay, so that's a direct use of the formula. Okay, so for our second example, so for letter B, we have u is equal to sine squared of 3t. Okay, so this now will not be a direct use of the formula, because as you can see, we don't have a formula for the derivative of sine squared. Okay, so what we only have is the derivative of sine, okay, but not sine squared. Okay, so for this problem, we will be using the general power formula. So we will transform this. This will become u is equal to, so to avoid confusion, so let's emphasize the meaning of sine squared 3t. So the meaning of sine squared 3t is sine of 3t squared. Okay, so in this problem now, so in this type of function, so we can now use the general power formula, where our u is this one and our n is 2. Okay, so applying the general power formula, this will now become du over dt is equal to, so applying the general power formula, so 2 will now be multiplied with the coefficient, so 2 times sine of 3t raised to 2 minus 1 multiplied by the derivative of what's inside the parenthesis. Okay, so the derivative inside the parenthesis is, so the function is sine of 3t. So the derivative of sine is cosine. So if our u here is 3t, okay, so if our u is 3t, then its derivative will be cosine of 3t multiplied by the derivative of 3t. So the derivative of sine 2t is equal to, the derivative of sine 3t is cosine of 3t multiplied by the derivative of 3t with respect to with respect to t, I mean. So this is times 3. Okay, so that's the general power formula, okay, and the chain rule. So du over dt will now become, so 2 times 3, that is 6, and this will become sine 3t cosine 3t. Okay, so you can have this as your final answer, or you can still simplify this using the using the identity, the double angle identity. So if you have sine of 2a is equal to 2 sine a cosine a. So therefore, sine a cosine a is equal to 1/2 of sine 2a. So in this case, our a is 3t. So 2a must be 60. Okay, so this will now become 6. So we will replace sine 3t cosine 3t with 1/2 of sine 6t. Okay, so therefore, the derivative, the simpler form of the derivative, so du over dt is now, so 6 times 1/2, that is 3 sine of 60. Okay, so again, the use of the derivatives will be very handy in simplifying our final answers. So the next is letter C. So letter C, we have, y is equal to x squared cosine squared of 3x. Okay, so again, to emphasize the squared, so we will rewrite this as y is equal to x squared times cosine of 3x squared. Okay, so this type of function now will be derived using the product rule. Okay, so where in our product rule, this is our u and this is our v. Okay, so the first factor multiplied by the derivative of the second factor plus the second factor multiplied by the derivative of the first factor. Okay, so therefore, our dy over dx is equal to, so copy the first factor, x squared, then multiply it by the derivative of the second factor. So this looks similar with our previous example, so we can use here the general power formula. So taking down 2 to be a coefficient, multiplied by copy cosine of 3x raised to 2 minus 1, multiplied by the derivative of cosine 3x. So let's review our formula. So the derivative of cosine of u is negative sine, okay, of u multiplied by the derivative of u. So here our u is 3x. So its derivative must be negative sine of 3x. Okay, multiplied by the derivative of u with respect to x. So the derivative of 3x with respect to x is 3. Okay, so we have finished deriving the second factor, this one. So next is plus the second factor, which is cosine 3x squared multiplied by the derivative of the first factor, which is x squared. So the derivative of x squared is, with respect to x, is 2x. Okay, so simplifying this, so this will now become, so 2 times negative times 3, so this will become negative 6, and then we have x squared, and then we have cosine 3x. Okay, plus this one, so plus 2x cosine squared of 3x. Okay, So this form is already acceptable, I think. So actually in our previous example, so actually in our previous example, so this is already an acceptable derivative. Okay, so this one, so it's already okay. So here, so this is also okay, so no simplification needed. So I just showed you the simplification. So in some cases, so say for example you have a multiple choice question, okay, where you have to fit your answer to the choices. Okay, so you have to simplify. Okay, so the last problem is we have this one. So y is equal to secant to the fourth theta tangent to the fourth of theta. Okay, so actually before you start deriving, okay, a function, so you must also see if it can be simplified first, okay, before deriving it. Okay, so as you can see, we have here difference of two squares. Okay, so if we factor that out, so this will become y is equal to secant squared theta plus tangent squared theta multiplied by secant squared theta minus tangent squared theta. Okay, and from the Pythagorean identity, if you will recall, that tangent squared theta plus 1 is equal to secant squared theta. Therefore, secant squared theta minus tangent squared theta, if we transpose this, is just equal to 1. So therefore, we can replace this with 1. So therefore, we can simplify our our function as y is equal to, so since this is equal to 1, so we can just simplify it as secant squared theta plus tangent squared theta. Okay, so next is we can derive this now. Okay, or we can still simplify if you want. So if you want to replace secant squared theta with 1 plus tangent theta, so that is also okay, so no problem with that. So we'll have y is equal to secant squared theta is tangent squared theta plus 1 plus tangent squared theta. So simplifying this, so this will become y is equal to 2 tangent squared theta plus 1. Okay, so look how our function became very simple. So from this to this, using only one identity. Okay, so we can now derive this. So, but before that, let us transform tangent squared theta into tangent theta squared. Okay, so dy over d theta will now become, we have a numerical coefficient of 2, so write that, multiplied by, so this one is obviously a general power formula, so we have, so coefficient of 2 times tangent of theta raised to 2 minus 1 multiplied by the derivative of tangent theta. From our formula, the derivative of tangent theta is secant squared. Okay, so times secant squared theta multiplied by the derivative of theta with respect to theta, so that is 1. and then of course plus, so we forgot the plus 1, sorry. So plus derivative of constant is 0. So simplifying this, so this will become dy over d theta is equal to 4 tangent theta and then secant squared theta. Okay, so it's fairly easy if you memorize the derivatives, okay, of the trigonometric functions as well as the identities. Okay, so it is very important that you review your identities and know when you should simplify your functions. Okay, so that's all for this video. So good luck.